This recording is for grade 10 students to prepare for the final exam on linear systems. This is the question that was offered about Sophia and Benjamin. Please pause the video and read the question so that you know exactly what's happening here. As we read the question, we underline important words. First sentence doesn't really have any important information. Second sentence, we have Sophia. She charges this much plus supplies this much. We have Benjamin. Charges this much and rate of this much. Okay, and then there are some suggestions as to what letters we should use. C, total cost, and number of hours they work at the party. So what are these things represent? Sophia, flat charge, $30, and rate of $9 per hour. Benjamin, flat fee of $20 and rate of $11 per hour. Our usual linear equation should look like y equals mx plus b, where b is the flat rate, flat fee, and m is the hourly rate. Looking at this, we will be able to quickly figure out that flat fee $30, that's b, and $9 is rate, which is m. In case of Ben, that's flat rate, that's b. So we will have 9x plus 30. And for Ben, we will have 11x plus 20. And it's almost good, except that that's not what we should be doing. We should use C and N. So we should properly rewrite the pink equations so that they use letters C and letters N. So for Sophia, C of N will be 9N plus 30. That is cost, depending on the hours worked. 9 times hours plus 30. For Benjamin, cost, depending on the numbers of hours worked, will be 11N plus 20. Now we should draw this, graph the lines, explain the point of intersection. Okay, so the point of intersection, let me solve for the point of intersection algebraically separately. So question C, point of intersection. Point of intersection 9N plus 30 equals 11N plus 20. That is the point of intersection of the two graphs. I set the equations equal to each other. So next thing I do, I get groups, letters on one side, numbers on the other side. So 30 and 20 are like terms. They'll be combined on the left. And when 20 moves to the left, it changes sign to a zero, sorry, to negative. When 9N moves to the right, it also changes sign to a negative. So I have 10 equals 2N. From here, N equals 5. When N equals 5, it's not very obvious what I wrote here. N equals 5. When N equals 5, what would the cost be? For example, for Sophia, 9 times 5 plus 30 should be 95. For Benjamin, 11 times 5 plus 20, 995, 75. This is 45, 4 plus 3 is 7. Sorry. 55 plus 20 is 75. Same, which is expected. And now let's try and graph them. We should put some names for axes. Now the choice of this grid is justified because we are working with real life situation. The number of hours worked should never be less than 0. The cost should never be less than 0. Hours, cost will be in dollars. Okay, so now quickly thinking about some costs, we have such numbers as 20, 30, 75. So maybe this unit will be 10, 20, 30. And 15. So I'll pause for a second to think about how to better structure my axis. Give me a second. So I decided that on my hourly scale, I'll have 1, 2, 3, 4, 5. And when n is 5, Sophia will be 75 and Ben will be 75. So let's find that point. 75 about here. Double check. 10, 20, 30, 40, 50, 60, 70, 75. That's 75. Now Sophia graph starts at 30, just here, and I should draw a line for Sophia starting at 30, going through this point. And Benjamin's line should be starting at 20. That's Sophia. In pink. And now Benjamin starts at 20 and goes through the same point right here. And very soon they intersect because we found the point of intersection. Point of intersection, 5,75. And now the meaning, what the point of intersection represents. So let's see. So Sophia starts working and everything from 0 to 5 hours, the pink graph is higher than the blue graph. That means that during the first 5 hours, Sophia costs more to employ than Ben. After 5 hours, pink graph is lower than blue graph, which means that after 5 hours of work, Sophia costs less to employ than Ben. So 5 hours is exactly where their cost is equal. For 5 hours of work, it costs as much to employ Ben as Sophia. Last question would be whether you would hire Sophia or Ben for work. So here is where you write your detailed explanation. How long is your party? That's basically the bottom line. How long is your party? If your party is between 0 to 5 hours and you want to save cost, you hire Ben. So maybe I'll write here the answer for E. For a party that lasts from 0 to 5 hours, hire Ben because Ben is cheaper. For a party that lasts exactly 5 hours, doesn't matter, their costs are equal. For a party that lasts longer than 5 hours, then it is cheaper to hire Sophia. And the point of intersection right here is equal cost to hire Ben or Sophia. And that equal cost happens at 5 hours. So that's how you solve this problem. The next section is applications of exponents. Question comes from physics, so I'm going to explain you how to solve it. Motion of a moving object can be modeled by a formula right here. D of time is the distance traveled by the object in meters. T, the time is taken by the object to travel, probably fall down on the ground in seconds. Second. Initial velocity of the object in meters per second. Acceleration, which is equal to this number in case of a free fall. So that is just the setup. That's the introduction to the problem. The actual problem starts here. A flower pot is knocked off a window ledge and accelerates uniformly towards the ground. Window ledge is 10 meters above the ground. How long does it take for the flower pot to reach the ground? So a quick illustration. Let's say there's a flower pot somewhere here. Let's put a star here. That's the flower pot. And it's knocked off the ground and it's going to fall down. Boom, 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 boom. And then it'll be crack. Boom. Nothing left. Total height traveled, 10 meters. Question is, how long does it take to fall to the ground? In other words, time. Time is a question mark. And you have to be using this formula. So in this formula, the initial velocity of a flower pot is 0, which means that instead of VI, you'll put a 0. And then if you put a 0, then anything multiplied by 0 is 0, so this whole piece is gone. So the actual equation that you need to work with looks like this. 1/2 AT squared. And more so, we know the A. A is 9.8, so actually you work with 1/2 9.8 T squared. And now more so, you can divide 9.8 by 2 to make your life simpler. And you get 4.9 T squared. So we have simplified this as much as we can. And now we can start reading the question again. That the flower pot is knocked over 10 meters above the ground, which is this distance. And how long does it take? That's the only unknown question mark. So all we need to find, we set d equal 10, 4.9, t squared. The only unknown is t. So here are steps to find t. So we divide 10 by 4.9, and that would be time squared. And try and keep it like fairly, accurate, because time is small. And it makes a big difference to use accurate numbers. When I divided 10 by 4.9, I got many digits. So the more the better, because the more accurate your result will be. And then here's the key move. You should take a square root out of this number to find time. Okay, square root out of 2.0408 is 1.428565. That it's a lot of digits than after. I'm just rounding up. Hopefully the question will say how you should round up, but if not, I'd say 2 digits is good enough. So let me round up by this number. After 42, there is 43 seconds. Units of measure, seconds. Okay. And that's how long for the pod to fly and down. So it's always a small number. 10 meters, the object will travel very fast. It's a blink of an eye. 1 second, less than 2 seconds, and it's down on the ground. So if you received something 4 seconds, 5 seconds, that's most likely incorrect, unless this was a huge height. So keep an eye on the reality and remember to put your units of measure in place.